Well, I hope you all had a really nice Easter weekend. I'm sure it was different than it usually is, but I hope you found a way to have some joy and enjoy your family and friends. Um, so back to the unit circle. So here we go, 8.4. We're going to stick with degrees just a little bit longer. I think they'll be more familiar and it will be a nice way to go. So 8.3b homework had you keeping in mind important ideas such as what are these angle measures? So right here, when we're at the point 1, 0, we're going to call that angle measure 0 degrees. When we were here at point 5, 0.866, we were at 30 degrees. Right here, we were at 0.707, 0.707, and 45 degrees. Here, we did the flip, 0.866, comma, 0.5, and we were at 60 degrees because 60 and 30 are complementary angles. Excuse me. Up here, we're at 0, 1, and we're going to call that 90 degrees. And then we decided all of our reference angles could happen. So the numbers that I wanted you to remember were numbers like 120 degrees and 135 and 150. Over here, when we're at negative 1, 0, we're at 180 degrees. We're going to then add our reference angle of 30, so now we're at 210, 225, 240. Down here, at 0, negative 1, we're at 270 degrees. 300, 315, 330. Over here, all of our 0.5, 0.866 is going to be the same point we have here, and the same point we have here, and the same point we have here. At 45 degrees, 0.707, we're going to have those same numbers here, the same partners here, and the same partners here. At our 60 degree mark, we're going to have those same numbers here, here, here. And as we know, it's just here we're going to have a negative x value and a positive y. Here we'll have negative, negative, and here we'll have positive, negative. So that kind of gets us started. So today's lesson is really about these numbers. 0.5 is in fact an exact value, but 0.866 is rounded for an exact value, as is 0.707. And both of those numbers are numbers that come from square roots. So that's our lesson for today. We already talked a little bit about these nice numbers. Oops. So sine of 90. So at 90 degrees, we're pointing in this direction, and sine is the y value, so we're at 1. Cosine of 270, now we're pointing in this direction. The x value is the cosine value, so we're at 0. Sine of 0 is the y value. Cosine of 180 is the x value. And tangent of 90, that's the slope of this line. Oh, the slope of that line is undefined. We could also find that by saying y over x. And when we take y divided by x, we get 1 divided by 0. Oh, we know that's an undefined number. But where do those other numbers come from? They come from our special right triangles. So let's start with a look at some 30, 60, 90 triangles. Here goes way back to when we made those triangles and we decided there was a relationship between the hypotenuse, the short leg, and the long leg. So here, if the short leg is 8, we know the hypotenuse is 16, and the long leg is 8 root 3. Just following these patterns. Here, if we know the short leg is a half, we know the hypotenuse is 1, and the long leg is root 3 times 1/2, or root 3 over 2. Over here, if we know the short leg is 14, we know the hypotenuse is 28, and the long leg is 14 times root 3. Well, this is going to be kind of special because when we look at our unit circle, we know the hypotenuse when we're at this point B. If we think about it as a right triangle, it's a 30, 60, 90 triangle, and because it's a circle with radius 1, our hypotenuse is 1, so that makes our short leg a half and our long leg root 3 over 2. The vertical piece is the y value, the horizontal piece is the x value, so root 3 over 2 1/2 is our point. That means cosine of 30 degrees is equal to root 3 over 2. And sine of 30 degrees is 1/2. That means we can find this point over here at 150, this point at 210, and this point at 330. They're all going to have the same x and y magnitude values. They're just going to change signs. Well, let's look at another triangle. Instead of a 30, 60, 90, we can call this a 60, 30, 90. In that case, once again, our hypotenuse is 1, our short leg is a half, and our long leg is root 3 over 2. This horizontal distance would describe the x value, the vertical distance would describe the y value, and there's the location of our point. That means that cosine of 60 degrees is equal to 1/2. Sine of 60 degrees is equal to root 3 over 2. We know those same locations are going to happen here, 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 and the angle measures there are going to be 120, 240, and 300. So all of those are going to have the same combination, just changing of positive or negative. So that already gets us a lot of points. We have one more triangle to look at, and it's a 45, 45, 90. And what we remember from this pattern that happens, we multiply to get the hypotenuse, or we divide to get the leg. So when we do that, if the short leg is 8, well, this one's going to be 8, and this one's going to be 8 times root 2. If this leg is 14, this leg is 14, and this one's going to be 14 root 2. Here we're given the hypotenuse. That means each leg is 18 divided by root 2. When we're on the unit circle, our hypotenuse is 1. That means these are 1 over root 2. If you prefer 1 over root 2, when you multiply by root 2 over root 2, you get root 2 over 2. In textbooks, you will oftentimes see this. There's also a memory trigger that we'll talk about to help you memorize these values, that root 2 over 2 works better. I personally have absolutely no preference. You may use either root 2 over 2 or 1 over root 2. So what that tells us is cosine of 45 degrees is 1 over root 2 or root 2 over 2. And sine of 45 is 1 over root 2, which is the same as root 2 over 2. We know we're going to get that same location at all those reference angles of 45. So at 45, and then we're going to get another one here at 135. We'll get another one down here at 225, and another one here at 315. With this information, this is all information you need to memorize. So you'll want to go over this a few times. And you're going to have a lot of practice problems that look like this. So here, if you look at this row right here, these are all reference angles of 30s. So right here, 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 and here. These are all reference angles of 60. Notice they're all multiples of 60. That's going to happen here, 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 and here. So those are all going to give you the same values, other than tangent, of course. And then our last one, these are all reference angles of 45. So they happen here, 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 and here. Obviously, it's important what happens at 0, 90, 180, and 270 also, but those are just sitting on an axis, so they're not very difficult to recall. So sine of 30, so let's look at all of our yellow ones first. Sine of 30, let's see, that's the short one, that's going to be 0.5. Cosine of 150, that's the long one, which is root 3 over 2, and it's going to be negative. So negative root 3 over 2. Sine of 330, now we're all the way at this yellow one. It's the y value. Let's see, the y value is the small one, but it's going to be negative. So negative 0.5. Cosine of 210, we're in the third quadrant. It's the cosine value, so it's the root 3 over 2, which is the exact value for 0.866, and it's going to be negative, so it's negative root 3 over 2. Now we're on the blue ones, and so cosine is now the small one, so it's 0.5. Notice that when it's 30 and 60, the x and y values switch. The blue one for 240, now we're in the third quadrant, and the cosine value is still going to be the small one, 0.5, but it's negative 0.5. Sine of 300, we're over here at this blue one, and it's the y value, so it's the big one. It's the root 3 over 2, but it's negative because it's the y value. Tangent of 120, so tangent right here at this blue one is going to be the y value divided by the x value. Well, the y value is root 3 over 2. The x value is 0.5, or 1/2. That means tangent of 120, oops, but this one is negative. That means tangent of 120 is negative root 3. Over here at the purple ones, oh, these are easy because for sine and cosine, they're always root 2 over 2, or 1 over root 2. So root 2 over 2, which is the same as 1 over root 2. Cosine of 315, you're in this quadrant. X is positive there, so you're root 2 over 2, which is the same as 1 over root 2. Tangent of 225, oh, it's slope. I don't have to worry about this thing. This is a little trickier. We'll talk about ways to memorize that, but you know your slope is either 1 or negative 1 there, and it's definitely negative 1. Cosine of 135, the cosine is negative in that quadrant, so it's negative root 2 over 2, which is the same as negative 1